just learning how to graph quadratic functions. Just review.
This is
Uh,
what's the one to answer.
no, this is just 2.1. 2.2 we'll do tomorrow. Yeah. And honestly, the thing is that not everyone remembers stuff they learned like math one, math two, and even just math three. Like, the time you guys had from the end of math three summer and then coming back to school, like a lot of students just forget the stuff unless you
I
like
remember
math.
most of like the equation based stuff, but I have the TA for math 1B, and I low-key feel bad in a way because I don't know part of it because it's like the most tedious things.
Yeah.
Like it's like they're doing like P equals or P to Q to R.
Oh,
And
that
like
stuff?
yeah, and you
Yeah.
have to know the table off the top of your head like
Yeah.
true plus true equals true, plus false
Yeah.
equals
I remember,
false.
I know which one you're
Yeah,
talking about.
yeah,
Yeah. Yeah.
false, false.
I mean, that's honestly mostly used in statistics. It's not really used in
I
higher
hate
level math.
statistics so
So,
much. That was
yeah.
our most of our second semester of math three, and it was terrible.
Yeah. 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 I agree. I agree.
I don't remember like any of that, but I could probably it wouldn't take me long to refigure it out. But I don't want to relearn how to do
Yeah,
statistics.
exactly. And you actually don't need it for higher level math. So it's only if you actually ever take statistics. So yeah, but we still teach it to you because honestly, stats is probably the fundamental of math that you actually use in the real world more than you would if than functions and stuff like that. So that's what's still taught in high school. Okay, quadratic functions are polynomials of set degree. Graph is a parabola. They're symmetric with respect to the line or axis of symmetry, and the vertex is the turning point of the parabola, which it gives you either the min or max. So just a lot of just review of quadratic equations. I need to bring up the notes for this. Okay. So for the general quadratic form, we have f of x is equal to ax squared plus bx plus c. If a is positive, it opens up. If a is negative, it opens downward. If a is greater than 1, you're going to have a narrow graph. If a is between 0 and 1, it's going to be a widened graph, wide. Um, so you should know the formulas already, the axis of symmetry. Spell it correctly. Axis of symmetry. It is annotated by x equals negative b over 2a. The vertex is negative b over 2a. So when you plug in the axis of symmetry, you'll get a y. So that's what's it called? The min or max of your graph, depending on whether it's opening upwards or downwards. You need the axis of symmetry to plug it into the function to get your min or max. And then the last thing you need when you're graphing these types of equations is finding the y-intercept. So as you know, the y-intercept is where the graph crosses on the y-axis. So um, this is when x is equal to 0. Or another form you can write it is that the axis, the y-intercept is just the constant at the very end of the function. So it's annotated by 0 comma c or y is equal to c. The other form is the standard form of quadratic function, a equals x minus h squared plus k. The axis of symmetry is x equal to h. And then the vertex is just h comma k. Does anyone have any questions? So a quick example. I gotta change the color. A quick example is when you have y equals 2x plus 2 squared plus 3. In this case, your vertex is going to be negative 2 comma 3 because you have to plug in negative 2 into the actual function, sorry, into the formula to get you positive 2. So it has to be negative 2 when you take it out of the quadratic standard form function. So it's going to be -2, comma 3. To solve ax squared plus bx plus c, you have to do by factoring. Now, there's two methods to doing this. You can either do the diamond method or actually taught the math 2 class a different method to actually do the factoring. It's actually pretty neat. And honestly, it's a lot simpler than the diamond method. But if you wanted to do the diamond method, because that's how you were taught last year, or how did Mr. Fessenden teach you guys on the factoring quadratic equations?
I think he taught us a different way, but I kind of forgot what. Oh, you remember what other way is? I don't know. I remember you teaching us a different way than.
So there's diamond method, there's grouping. Grouping is actually the hardest method, and then there's another method I actually learned online. Well, I'll teach you guys when we get to the problems, but you how you factor just really depends on you. Just know you have to get factor. Okay, so the either factoring you are using the quadratic formula, which I'll give you the formula, which in this case it is
Plus or minus.
oh, x equals -b plus or minus the square root of b squared minus 4ac divided by 2a. So
I can't see the second half.
sorry, give me a quick second. I don't want to mess this up again, so do it this way. Okay. So here's the first example. Sketch the graph of the quadratic function, identify the vertex, the x-intercepts, and all the great stuff. So we're gonna do this step by step. So finding the vertex, x equals -b over 2a. So you gotta know your values. So b is this case is -8, and a is just +1. Negative times a negative is positive. 2 times 1 is 2, which will give you 4. So after doing all of that, all you gotta do is just plug it in. So f of 4 into my function. 4 squared minus 8 times 4 plus 16. So once you do all of that, you plug it in, you'll get 0. So that means my, sorry, this should not be called the vertex. This is actually the axis of symmetry. Now, the last part is the vertex. So after plugging in 4, we get 4 comma 0. The y-intercept, it's the last constant. So in this case, it's just 16 comma 0. Sorry, wrong way. 0 comma c. To check 0 squared minus 8 times 0. Intercept. Okay, last part, you can find the x-intercepts. And all you have to do is just factor x squared minus 8x plus 16 equals 0. So now, you could do the quadratic equation for this, but the way I taught math too, it's just a lot easier and it's like less having to, have to plug it all in. Which in this case, you just have to, when a is equal to 1, this is be careful. When it's a is equal to 1, all you have to do is find two numbers that multiply to your last term, or in this case, c, and two numbers that multiply to the middle term, which in this case is -8. So to find your two values, you just need to find the factors of 16. 1 and 16, 2 and 8, 4 and 4. And that's pretty much it. So out of these three pairs, you need to find two numbers that multiply to 16 and add to -8. The only pair is -4 and -4. -4 times -4 is +16. -4 plus -4 gives me -8. And then the only thing you have to do is when you write the factored form is you just write it as a last term in the binomial. And you can double check, do the box method, distributor method, and it turns out when you simplify this, you'll end up getting x squared minus 8x plus 16. So that means my x-intercepts is when you take each of the binomials and you just equal it to 0. So x equals positive 4, it's minus 4. So x equals 4. So that's my x-intercept, that x equals 4.
Does that mean there's only one intercept?
That is correct. Now, the important part is that there's two of them. Hopefully, you guys learned in Math 3 last year that if you have the factor form and they both are exactly the same, then it bounces on the x-intercept. It doesn't go through. When it's even and there's two of them, there's even number of factors, then it will just touch the x-axis and then bounce right back up. So make sure you guys remember that because it's going to come up again in the future. All right, we have everything we need. So we have the axis of symmetry at x equals 4. So x equals 4. Now you want to do these as accurate as possible. Accuracy is key. We have the vertex at 4, 0. And then we have the y-intercept at 0, 16. So in this case, I'm going to erase my y coordinates and I'm gonna rewrite them because there's not 16 in here. So I'm gonna go by 2s. So the the x-axis is gonna go by 1s, but for my y-axis, I'm gonna rewrite it in terms of 2. So 2, oops. 2, 4, 6, 8, 10, 12, 14, and then 16. So then at 0, 16, that is the y-intercept. Now, as I've told you guys before, whenever you're graphing, you need at least 3 major points aside from, the major points in this case. So the reason why I drew the axis of symmetry is because the coordinate of the y-intercept from the axis of symmetry is exactly the same length or same distance on the other side. So from 0, 16 to x equals 4, there's 4 units. So that means if I want to go on the right-hand side, all I have to do is go 4 units to the right-hand side. So 1, 2, 3, 4. Oops. 1, 2, I cannot count. 1, 2, 3, 4. So that means on the other side, 1, 2, 3, 4. And then you have a dot. And I can get this dot because I use the axis of symmetry. Remember, the axis of symmetry means you cut the graph perfectly down the middle. So whatever distance you have from every coordinate on the left-hand side, it's going to be the same distance on the right-hand side of the axis of symmetry. And when you graph it, I expect you guys to be as accurate as possible when you do these. And you'll have a graph looking like this. And that's your answer. And then this case, this coordinate right here is 7, 6. Oh, sorry, 8, 16. I wrote it wrong on my notes. 8, 16. And we just proved it. So see how we had x minus 4 as the x-intercept? There's even. So that means it actually bounced on the x-axis at x equals 4. So it's a neat little trick. If it's odd, it goes through. So if there's an odd numbers of x-intercepts of the value, it goes through. But if it's even, it bounces on the x-axis. Okay, let's go on to the next one. Okay, it says write the standard form of the quadratic function that has the indicated vertex and whose graph passes through the given point. Hint, use standard form. So standard form, SF, is y equals ax minus h squared plus k. Now, luckily for us, we already have the vertex. H is equal to 4, K is equal to -1. So all we have to do is just plug that in. Y equals AX minus 4 squared minus 1 because K is -1 and then H is just 4, so it's X minus 4. Now, the only thing now is to solve for A. That's the only thing we're missing. Luckily, we have a coordinate, which is 2, 3. We're going to plug this coordinate into our function to solve for A, to isolate the variable. So Y is 3, 2 is X, and all you have to do is just simplify. -2. I'll add 1 to both sides. So you'll get 4. -2 squared is +4. Divided by 4 is equal to +1. So I have everything I need. Just plug it into the function. Y is equal to A, which we found out to be 1. And then everything else just stays the same. Does anyone have any questions? So this concept right here is very, very important. Anytime you have a formula and you're given certain coordinates, you got to use what you have to solve for the missing value. So in this case, the missing variable of A. So this concept is actually going to come up a lot. So please make sure you understand that of, how to isolate variables with what you're given and then the formula that you're given. The last one, minimum, maximum values of quadratic function. If A is greater than 0, it is you're gonna have a minimum, so that means it's gonna open upwards. Your minimum is gonna be that coordinate right here at the vertex, and then if A is less than 0, meaning if it's negative, it's gonna open downward, and you're gonna have a maximum. So it's just how the graph is. All right. The path of a diver is given by the below equation where y is the height in feet and x is the horizontal distance in feet from the end of the diving board. What is the maximum height of the diver? Now, because A is less than 1, less than 0, sorry, you will have a maximum. So that means I have to find the vertex of this equation, and that will give me the maximum height. Any questions so far? So, first things first, axis of symmetry. -24 divided by 9 divided by 2 times -4, 9. So please make sure you guys know how to multiply fractions. Do not get confused. So -24 over 9. Now the other one is -8 divided by 9 when you multiply by 2. And now you do KFC, keep, flip, change. You keep the numerator and you change it to from division to multiplication, and then you change then you flip it.
The right wrong order.
Which one?
KFC.
Is it KCF? Keep, change, flip. Oh yeah, you're right.
I
Some teachers just write it as KFC. So so keep, flip, change. Oh, actually, no, yeah. So it just depends on how you write, on how you say it. You can say KFC as keep, flip, change, or keep, change, flip. So yeah, KFC is just funnier.
I'm used to KCF, but I thought about it before. I'm like, can we do KFC? It
Yeah.
sounds funnier.
Yeah, you can. The only thing is you just gotta make sure you flip this and you change it from division to multiplication. The only thing now you have to do is just reduce. 8 goes in 8 once, -24 goes into 8 goes into -24 3 times. They're both divisible by -3. And then 9 goes into 9 once. 3 times 1 is just 3. 1 times 1 is 1. So that means my vertex is at x equals 3. Okay, so that means to find the height or the y coordinate of my function, all I gotta do now is just plug it in. Negative 4 over 9, 3 squared plus 24 divided by 9 times 3 plus 12. Okay, 3 squared is 9. Oops, and that should be 3, 9. That should be 9 at 3. Plus 24 divided by 9 times 3 plus 12. Okay. 9 and 9, when you're multiplying any fraction by the denominator, they just cancel out. So you're left with negative 4 for the first term. 24 divided by 9 times 3. These are both divisible by 3. So you're left with 24 divided by 3, which is actually 8 plus 12. Negative 4 plus 8 plus 12 is 16. So my vertex is 3 comma 16. 3 represents the horizontal length. In feet, by the way. And then 60 represents the height, right? Because that's the y coordinate. It's how high you're going. So that means at 3 comma 16 is when the person from the diving board is going straight down, was going down as time goes on. So that means the maximum height is 16. Does anyone have any questions? All right, that's pretty much today's lesson.
Sure. Didn't you figure out the maximum height at by just? I mean,